This video is the first video where I'd like to go over some information with you about transformations. You might remember from your Algebra 2 class where you might have the parent function y equals x squared, and then you were able to do a transformation using this idea, ax minus h squared plus k, where you'd end up with a vertex at h k, and it caused your parabola to move around different places. And depending on the sign of your A, you may have even taken your parabola and flipped it over. Okay? So in our world of transformations, a couple of types. It could be a rigid transformation, and that means that you're going to leave the size and the shape unchanged. It's going to be the same. Size and shape, same. Things like horizontal or vertical translations. Okay, horizontal, vertical translations, reflections. Those are going to be rigid transformations. You're not going to change the size and shape of your whatever it is, your graphic, your parent function. You're just going to move it around. Okay, move it around, slide up, down, left, right, flip, stays the same. If it's a non-rigid transformation, that's when you're going to get some kind of a distortion in what you're seeing. Okay, so it's going to distort the image. Okay, something that does that is a horizontal or a vertical stretch or shrink. Okay, and that will be talked about in the second lesson that we do, second video. Okay, all right, so let's start first with vertical shifts. Okay, if you have something like y equals f of x plus c, okay, f of x plus c. The plus c is outside, away from that function. We're talking about moving up by c, whatever c is. If it's a 3 sitting there, you go up 3. Okay? If you do y equals f of x minus c, you're going to move down. Okay, so that would drop your parabola, or whatever your parent function is that you're shifting, would drop down. Okay, so kind of the idea is if c is outside the parentheses, okay, you're looking at an up and down, or a vertical shift. Okay, for example, if you do like y equals 2x plus 3, okay, 2x, you have your line, plus 3 means you're going to move that up 3. Okay, if you do something like y equals 2x minus 5, okay, so 2x is your line, minus 5 means you're going to go down 5. Okay, so those are a couple examples for verticals. Horizontal shifts might look something like this. Y equals f of x minus c. Okay, so if it's inside the parentheses, we're talking about horizontals. So in this case, we're going to go to the right by c, whatever it happens to be. Okay, if it's y equals f of x plus c, okay, that one's going to go left by whatever c is. Okay, so I guess we could make a little statement that if c is inside your parentheses, you've got a horizontal shift happening. You just got to remember the signs on the inside, you're always moving the opposite of whatever that says. Okay, so a couple of examples down here. How about y equals parenthesis x minus 3 quantity squared. Okay, so that minus 3 is going to mean you're going to move to the right 3. If you have something like y equals parenthesis x plus 5 quantity squared, okay, again, this part on the inside means you're moving to the left 5. Okay, so that part takes care of your vertical and your horizontal shifts. Okay, what would it look like if we put something on here? Let's say we have a parent function. Oh, let's pick absolute value just for fun. okay? And if I sketch a quick graph of that, just nothing real fancy. Okay, so the parent, 0, 0, it would be a 1, 1, negative 1, 1, 2, 2. And again, I'm just doing a quick sketch to get the idea here. Okay, so there's your parent function. Okay, absolute value. Okay, then maybe I'll say to you, well, what if we did something like f of x equals absolute value of x minus 3. Right, so you got to think about that. You are inside the quantity. So if it's inside the quantity, we're looking to do a horizontal shift. Okay, so in this case, it says go to the right 3 and then draw your parent function. Okay, so we'll go over here, 1, 2, 3. So all the points are going to move 3 to the right. So from 0, now we're at 3. Okay, so instead of over here, up 1, right 1, we're going to go up 1, right 1 from here. Okay, and we're going to draw this way, left and up, and this way. Okay, so this one, we did a shift to the right. All right, maybe we can have another quick graph, absolute value of x, minus 3. Okay, so this one is outside. So that means we're going to do a vertical shift down 3. So we're going to come down on the y-axis to negative 3, drop all of our points from our parent, down 3. So down 3, this one's going to come down, this one's going to come down, and you'll have your graph down here. I'm trying to stop so you can see the shifting moving around. Okay, so that's what it looks like when you have your vertical and horizontal transformations. All right, so if you bear with me a second, let me get this out of the way. And we can finish up with a reflection. Okay, so we could add reflections into this one. So we could do reflections. How about we start with across the x-axis? So if that's the case, we would do y equals the opposite of f of x. Or you might even think about, we're going to take for every point x, y, and you're going to go across the x. That means you're going to have the same x, but the opposite of y. That's what this is saying right here. Okay? If we want to do reflect across the y-axis, okay, that means for every point that you have, wherever you start, okay, this time you're going to do the opposite of x and keep the same y. So in other words, this one would look like y would equal f of negative x. So you're going to change the sign on your x's. So if you did a quick little drawing over here, maybe I have a point A with a coordinate of 3, 2. Okay? And you could do this for multiple points. I'm just going to show you with the 1 point and see what it looks like. So you're over here at 3, 2. This is your point A. Okay? So if we want to reflect across, okay, I guess it doesn't matter. We could reflect across, we'll just go in order of your notes here, the x-axis. Okay, that means you're going to take the point 3, 2. Okay, so 3, 2, and you're going to flip across x. So you're coming down this direction, so you're going to keep the same x and the opposite of y. So you're going to be at 3, and then you're going to go down here to negative 2. Okay, and I'll call that one A prime. Okay, so we went across x. Then secondly, if we want to go across the y-axis, you're going to take 3, 2. Okay, so if it's across the y-axis, we're going to be negative x, y. So it'll become negative x, so negative 3. The y stays the same. So we're going to go from 3, 2, and we're going to go over here to negative 3, 2. Okay, and that would be like a double prime or something, whatever you want to call it. Use a little geometry language there. Okay? So I think that looks pretty good as far as moving a point around. Just like in class, I dropped the eraser. All right, let's do one more algebraically, and I'll let you go for today, okay? All right, so maybe we have something like f of x equals 5x minus 9 all over x squared plus 3. And maybe I ask you for the equation to reflect across the x-axis. Okay, so what does that mean? If I reflect across the x-axis, okay, so I'm using this part right here, x-axis, y equals the opposite of f of x. Okay, so our function would become, let's see, I can put it here. So we want to do the opposite of f of x. Okay, so we could put an opposite of 5x minus 9 all over x squared plus 3. Okay, so you can simplify that if you'd like. You can just take that opposite across the top. So changing signs. Okay, so if we were graphing, this new equation would be a reflection across the x-axis. Okay, if I ask you a similar question, equation to reflect across the y-axis, okay, so what would be the equation for across the y-axis? Looks like I caught this here. So y-axis is f of negative x. So in this case, we have to actually substitute in negative x to see what we get. So again, using this first equation, 5 times negative x minus 9 all over negative x squared plus 3. So we'd have negative 5x minus 9 all over x squared plus 3. Okay, so graphing this new equation, it should reflect across the y-axis from our original. Okay, and that's it for today. So we've taken a look at translations where we are doing left, right, up, down, as well as some reflections. Okay, thank you for watching, and join in to another video. We'll talk about vertical and horizontal stretch and shrink. Thank you.